with day 3 of our review. We're going to look at position, velocity, acceleration. This is to get ready for Theme Thursday tomorrow. We're going to look at a lot of free response questions that have to do with position, velocity, acceleration. It is almost a guarantee that one of your free response questions will be all about a position, velocity, acceleration scenario. This could either be on the calculator or no calculator part. And we just have to be ready for all things PVA. There's about, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, like 10 different things they could ask about. They'll probably ask about 3 or 4 of them. And we just have to be ready for all of them. Okay, so the first thing we know is how do we change between the given functions? Okay, so first off is position. Position is oftentimes used as x of t, but it could also be, sometimes they use s of t for position, sometimes they use y of t for position. Right? All of those things could be the position function. Probably the most common one I see is x of t. Velocity is v of t. Acceleration is a of t. Okay. To move down the ladder, we move down with derivatives. Okay? So if I have position and I want velocity, I need to do the derivative. If I have velocity and I want acceleration, I have to do a derivative. If I want to go from position all the way to acceleration, I have to do 2 derivatives, right? To go up the ladder, then, we have to do integrals. But we have a big problem as we climb up the ladder, is when we integrate something, we get that plus c coming out of it. Okay, we get an antiderivative with a plus c. So we need a specific point or two to help us figure out how we do it. But in general, moving up the ladder, we move up with integrals. Okay. Let's talk about units real quick. About half the time they have units on these, about half the time they don't. But if they do, position units are always in just a distance measurement. So something like position would be something like meter, feet, mile, any of those things. Velocity is the rate of change. Okay? Velocity is the rate of change of position. So it's a rate, so it's meters per second, or feet per second, or mile maybe per hour, something like that. Acceleration is then the rate of change of velocity. So it's meters per second, or feet per second, or miles per hour. Something like meters per second squared, feet per second squared, miles per hour squared. Okay, next. Sometimes they ask you about, on what time interval is something traveling to the left? If they ask you about a direction, going left, could also be down if it's an up and down thing. Okay. How do we know when something is going left? Well, its velocity would be negative. Our velocity would be less than 0. Going right, or if it's moving along the y-axis, going up, that's whenever our velocity is greater than 0. Okay? So, for example, let's say I have, I know v of t is equal to t squared minus 8t plus 12. Okay? And we're on the interval 0 to 10. So if they ask you, on the interval 0 to 10 here, where is the object, on what interval is the object going towards the left? Well, to figure out where something is going left, I just want to figure out where my velocity is negative. So what can I do? Well, to figure out where something is negative, right, if I had a graphing calculator, I'd graph this and see where it's below the t-axis or below the x-axis. If I don't have a calculator, well, then I want to figure out where my function v of t equals 0. Well, v of t is going to equal 0. Well, I have to factor this thing. So what numbers multiply to 12 but add to -8? That would be -2 and -6. So I'd get t minus 2, t minus 6. So that tells me that the velocity is 0 at t equals 2 and t equals 6. Right? Then we do a number line test, a velocity test, to test the signs. I'm going to plot 2, and I'm going to plot 6. So I'm going to test my velocity at 0. I'm going to plug it into the factored form here. 0 minus 2 is negative. 0 minus 6 is negative. A negative times a negative is a positive. I'm going to test a number between 2 and 6. I'll use 4. 4 minus 2 is plus. 4 minus 6 is minus. So the velocity is minus here. And then I'll test 7. 7 minus 2 is positive. 7 minus 6 is positive. Okay. I consider my bounds of 0 and 10. I can say, okay, this thing is going to the left between 2 and 6 seconds. Okay. If I wanted to know where the object was going to the right, I'd say from 0 to 2, union 6 to 10. Okay. So that's how we deal with going left or going right. Okay. Next question. They might ask you, when is the object stopped? Or they might state it as at rest. Well, something is stopped or at rest when it's not moving. When it's not moving, its velocity is equal to 0. So we do just like we did up here. When is this object at rest? It's at rest at 2 and 6. Okay. That's how we determine when something is stopped or at rest. How about change directions? Well, we know that when something is going left, it has a negative velocity. When something is going right, it has a positive velocity. So to switch going right to left or left to right, velocity must switch signs. So anytime they ask you, where does an object change directions? We look for v of t to change signs. So in our example up here, both at time t equals 2 and at time t equals 6, we change directions. Because at 2, velocity went from plus to minus. At 6, velocity went from minus to plus. So anytime they ask about changing directions, that's what we do. How about speed? Speed is very important. Speed doesn't care what direction you're going, right? The plus or minus on velocity just tells you the direction. Speed then is the absolute value of velocity. So speed equals absolute value of velocity. So if my velocity is -5, my speed is 5. If my velocity is +7, my speed is 7. It just always makes it positive. Where you need to be careful on this is they'll ask you, when does the object have a speed of 3? Well, what we need to remember then, this is usually on the calculator part, we have to remember that v of t, our velocity could be 3 and have a speed of 3, or our velocity could be -3 and also have a speed of 3. So we go to our graphing calculators and we need to graph +3 and -3 horizontal lines and find the intersections on the graph to report all those time values. When they ask this question on the AP exam, there's generally both a positive and a negative velocity that gives you that positive speed. Okay? Hopefully that's ringing some bells from before. How about this? Speeding up or slowing down? They might ask you, at t equals 10, is the object speeding up or slowing down? Well, to answer this question, we must consider two things, right? I need to know the velocity at that time, and I need to know the acceleration at that time. So let's say, for example, at t equals 2. Is it speeding up or slowing down at t equals 2? Well, I need to check v of 2, and I need to check a of 2. You must check both. One alone is not enough to tell you the answer. The rule then is, if the signs are the same, we're speeding up. If the signs are different, then we are slowing down. By the way, sometimes they use the word speed increasing or speed decreasing. It means the same thing as speeding up or slowing down. Okay? We must check the signs. If the signs are of both, if the signs are the same, we're speeding up. If the signs are different, we're slowing down. Okay, what if we want to know the total displacement? What if we want to know the displacement of an object? Well, that is simply the displacement of the object from A to B. Well, that's simply the integral from A to B of v of t dt. Just the regular old integral from A to B of v of t dt will tell you the displacement of the object. Where it started, where it finished, what was that total distance? Okay, what was the distance from where you started to where you finished, right? Displacement is different than total distance traveled. Okay? Displacement only considers where did you start and where did you finish and what was that difference. Total distance includes, right? So when I go from my house to work and back to my house, my total displacement then is 0, right? Nick, I know you're out there wondering about, well, the Earth actually spun. Okay. My total displacement relative to my house was 0. My total distance traveled, though, was like 10 miles. Okay? Because I went 5 miles to work, 5 miles home. To calculate total distance, then, total distance traveled again on AB, that will be the integral from A to B of the absolute value of v of t dt. Okay? That's how we do total distance travel. Okay? The last thing we want to know that they ask a lot is they want to know a position at a certain time. What is the position at t equals 5 if your position at t equals 1 was 7? Okay? So we want to know the position at 5. In order to figure this out, if we only have a velocity graph, I need an initial condition. Okay? So my position at 5 would be the initial condition plus the integral from the position I have to the time position I want of velocity. Again, this right here is just the displacement from 1 to 5. That's how much you changed in the time from time 1 to time 5. This considers where you started, right? So let's say my total displacement is plus 2. Well, then my position would be plus 2 from 7 would be a position of 9. Okay? Be aware, sometimes they ask for what is the position, right? What is x of 2 if x of 6 equals 10? Well, just be aware, the initial condition here is at a time value greater than this. Okay? So what this is going to look like, x of 2 then has to equal my initial condition of 10 plus my integral from the number I have to the number I want. Okay? Even though that integral is kind of back, like we think of it as backwards, right? We get the bigger number on bottom. That equation will still give you the exact location, position at x equals 2, or at time t equals 2. Okay. If you wanted to, if you were solving it by hand, if you wanted to, you could switch that to 10 minus the integral from 2 to 6 of v of t dt. Okay, that's all I can think of like the main questions that get asked all the time on this exam. They might ask some oddball questions too, and we just have to use our best knowledge to try and answer it accurately. We'll see a couple of those tomorrow. All right, that's it for today. I'm looking forward to working on some PVA problems with you guys tomorrow. Talk to you later. 2 chains. Bye.